So number 8. So we have 1 plus cotangent x over cosecant x is equal to 1 plus tan x secant x. So what do I need to do? Well, the only logical thing I can think to do is first, with this top, I want to break up that cotangent. So I'm going to say 1 plus cosine x sine x over cosecant. And then I can't add those top parts yet. Why? Don't have a common denominator. So if I do that, then this all now becomes sine x plus cosine x all over sine x. Still all over cosecant. Now, who thinks they know what I could do next? Our biggest thing is breaking things into sine and cosine because that helps. Do you think I could change this cosecant into 1 over sine? And then I'm going to flip it up. Then our sines cancel. And then from there, I'm going to do a little bit more because I don't think it would be clear what to do. Sine x plus, what is cosine x? 1 over secant x. And I chose to do that because my final answer, this is where you got to start looking at your final answer, has secant x in it. So now what should I be doing? Found my common denominator. Now, I'm going to tell you one more thing. I would change this back into something, and then I think things should cancel, and you'll get your answer that you want. Or no, secant is 1 over cosine. And that's all I'm going to help you with that one, because I know you have the knowledge to do it. Yes?
I think there may be like an easier way to do it.
Really?
Yeah. If you break the tangent up into cosine over sine, and then you multiply everything by that.
Remember, we can't do that when proving. Remember, we're taking the...
Just the one side, so you have like 1 plus cosine over sine over 1 over cosine, 1 over sine, because you can switch to secant, and then you times the 1 by cosine over sine, and cosine over sine by cosine over sine. I'm not gonna lie, can I show you on the board? I have it on my paper, and it makes sense.
And you got the same answer?
Yeah, and it was like 2 steps.
Okay, you can come show us.
And it just seemed like it was...
I'm just trying to... And that's where these can be tricky because there's more than one way to go about it.
Alright, so if you have and then that can switch into... So like any way to
Like up or down more?
more space, yeah. Alright, thank you. And then if you flip all that, you'll get stuck if you times that by...
Kids.
And that.
Yeah.
Oh,
Yep, and then that one, that's another way to do it.
well done, grasshopper.
Good job. So yes, yes. For my work?
Yeah.
The common denominator? Is that here you're talking about?
When you converted cosecant at the bottom to the secant,
Did you go all the way to the top?
wait, up a little more.
Oh, cosecant is equal to 1 over sine x.
So is that just
That's one of our identities. Yeah. Yeah.
I think the question is how you went from 1 over sine x there to the next few problems, secant x sine x was 1 over secant x. But I'm not confused by it, so I can't.
So here I did the reciprocal identity, and then I flipped it and multiplied here, and I canceled out. So now I'm just left with sine x cosine x. And then I guess I realized from the answer, because I didn't know what to do next from here, that secant x is on the bottom. So then I changed my cosine into 1 over secant again.
yeah, that makes sense.
Okay. That's okay. Yes.
Wait, Jason. So didn't the cosine and sine like they all cancel out the top?
When you multiply, you have to multiply it by everything, not just one term. Okay, good. So just some rules about proving factoring. On the homework tonight, there's a factoring problem that a lot of people were struggling with. Remember, if it's a difference of squares, you can factor it, and it will make some of these problems so much easier. If that's something you want to put on your list of things to remember, I would put that. Because some people were doing some really crazy multiplying things, and it would have been easier to break it up like this. Okay. The Pythagorean identities. People are still missing these. So on your sheet of paper, practice writing the 3 Pythagorean identities. Practice, practice makes perfect. I want all of you trying this with a sheet of paper.
Wait, is there anything else to do?
No, just some more practice and then,
Like the rest of the week, like order.
well,
Until the test.
I think the rest of this week is just practicing this stuff. Yes. Okay, the Pythagorean identities is sine squared of theta plus cosine squared of theta equals 1. That's one of our identities. This can be manipulated a little bit, and I think sometimes people forget what that can look like. So you can get that cosine squared of theta is equal to 1 minus sine squared theta. You can also get that sine squared theta is equal to 1 minus cosine squared theta. I don't remember these two. I just know from this one that I can get 2 more. And remembering that you can only use it when it's being squared. Okay, a second one. The one with the tan is what we seek. And again, we can manipulate this. So if you see secant squared minus 1, then you could put tan in for it. Tangent squared. And then our last one is 1 plus cotangent squared of theta is equal to cosecant squared. And again, we can manipulate that to say that cotangent squared of theta is equal to cosecant squared minus 1. I actually think that these identities are probably used the most next to like tangent, using cosine and sine of, tangent. These are really important, and I see people missing them a lot. So if you don't know them, just keep practicing them. And realize that we can still derive a few equations from the 3 main. Okay, so last week we started this whole unit with simplifying. So let's just practice with a simplifying one. On your sheet of paper, try this. So if you're getting this, I think you're in good shape. And yes, you're in good shape. So the first thing, remember my simplifying rules. I first looked to see if something was being squared. And then after that I did sines and cosines. And then my third thing that I like to remember is to factor. Because that is something that I forget a lot. Maybe you forget to distribute or something. But I always put factor because sometimes if I'm stuck on a problem, usually it's because I forgot to factor. But for this one, I first look, is anything being squared? Yes. And what is sine squared of theta plus cosine squared of theta? 1. So then I'm left with 1 minus cosecant squared of theta. Well, this is another identity. And what is that? Sine squared. So then I get 1 minus sine squared of theta. Okay? So I use the Pythagorean identity up here. And it appears that I might be able to use it again here. What is 1 minus sine squared? Cosine squared of theta. Who got that? Raise your hand. Good. Good, good. So we went from simplifying. What did we do after simplifying? It's another S word. We were trying to find the solutions to an equation. So we were solving, finding solutions. So on your sheet of paper, try this one. And I want you to find all solutions. There's no interval, so all solutions. What does that look like? About 10 more seconds, then we'll go over this. So I'm trying to look for solutions where cosine is positive. And there's how many spots where cosine will be positive? Yep, all students take calc. So 1 and 4. So if I draw my triangle, and it's adjacent over hypotenuse, and this is the angle, what will that angle be? 60. And then down here, we're still working with 60-degree angles, so we take 360 minus 60, and we get, is my answer complete? No, I said all solutions. So I have to say plus 360 degrees n plus 360 degrees n. If I would have put my answer into radians of pi over 3, then I would say plus 2 pi n. So we started with simplifying, and then we moved to solving solutions. And then lastly, we went to proving. So I have some proving reminders. Remember, you cannot do things to both sides. Usually we pick the left side, substitute in some of our identities to get it to equal the right side. And also remember that you're not going to want to like multiply anything by one side. You're just simply simplifying. You're not multiplying. You're not adding radicals. Just using your identities to simplify. Also, look at the answer on the right hand. Remember, look at the answer to the right hand. Did you see something, Aaron?
Yeah, you've got apostrophe after the T.
Oh, thanks. And then if you get stuck with these proofs, look at the final answer to see where you're headed or where you're supposed to go, because I think that helps. So, prove, practice, prove this. Work with the left-hand side and try to get it to 1, to equal 1. Everyone try. Did you get it already? Does this stuff make sense? No. Okay, so whenever I see 1 in a fraction, that kind of hints to me that the thing on the top must be the same as on the bottom, because it will come out to equal 1. So I'm going to work with the top, and I'm going to say sine of theta times, what is secant? 1 over cosine theta over tangent theta is equal to 1. What is sine of theta times 1 over cosine theta? And something divided by the same thing is, and 1 equals 1. So that's how you would prove that. Raise your hand if you got that one. Good.
Can you do it a different way?
There is another way. So let's do the second way in green. Thanks for reminding me. I wanted to do that. So, another way is, couldn't you just say, how did you do it?
Okay, I did sine of theta multiplied by secant of theta. Well, can I just write it because I don't want to like...
Yeah, you can come up. And that's what's tricky about these. There is multiple ways that you can do it. Neither of them's right or wrong. I can. That's okay. He'll move when he's done. Here, I got you. Yes. Aaron just showed us a second way to do it. And both are correct. Neither's right or wrong. His might have been a little bit longer, but doesn't mean that it's wrong. Yes. Are you looking at mine or Aaron's? Oh, you got it? Are you sure? Okay, so do you want to try another simplifying one? Let's simplify. I'll give you a minute. Try this one. Try this one. Simplify. Now we're not proving. We're back to simplifying. Everyone try simplify. Did you do it? So we're back to simplifying. So think about the 3 rules that I gave you. Is anything being squared?
What is that equal to?
Oh, we're simplifying, yep. I'm kind of being crazy like this because on the test, you don't know if it's going to ask you to simplify, prove, or solve. So simplify is just given. It'll say simplify. If it asks for solutions, then you'll have an equation. And then if it's asking you to prove, it will give you what they want you to get to. So the first thing is anything being squared. Yes. What is sine squared plus cosine squared? 1. So then I get that cosine of theta is equal to 1 plus sine theta minus 1. Yep, then the 1's cancel. So then I get cosine over sine, which is equal to cotangent.
So when we're doing proofs, do we have to always have like an equal sign?
So this is simplify. So no for simplifying, but for proofs, yes, you should be trying to write the equals. You don't have to write what's after the equals as long as you know where you're heading, but you should write the equals because that shows that you're proving every step. Okay, so with proofs, remember, it is important to show your work. Don't skip steps because if you skip steps, then you might lose some points. So one more proof. This is a proof now. Try this one out. Okay, so first thing I'm going to want to do is I want to change this tangent into sine x cosine x. I have 2 terms, but I'm trying to get it down to 1. So I have sine x cosine x times sine x plus cosine x, and making sure to put my equals. So I can multiply these. I don't need a common denominator because they're being multiplied. So I get sine squared of x over cosine x plus cosine x. And I just said that we started with 2 terms because that plus, or if you have plus or minus, it tells you how many terms. So we have 1 term, 2 term, and we're left with 1. So with this fraction, we're going to want to, with this fraction, we're going to want to find a what? Sorry. So then we get that sine squared of x plus cosine squared of x all over cosine x. What do you notice on the top? Yes, so that is 1. And then over cosine x. And then that equals secant. So, that's the last questions. Yes. So, in the red is what we had, but we needed a common denominator to add the top. So, I multiplied the bottom and the top by cosine. Okay, the last thing before we pass out the homework is I have 5 of the identities up here, and I want you to see if you, without a note sheet, I want you to see if you can find what these are equal to. For tangent, try to find 3 of them. This is for your practice, so don't cheat. Just try to see if you know them. And then while you do that, I'm going to pass out the homework. tangent of theta, see if you can find 3 of them. No, just 1 for each and then 3 for tangent. Okay, has everyone had a chance to do them all? What? So now, we're not going to really correct them, but I want you to kind of keep track of which ones you get right and which ones you get wrong. So, sine squared of theta is equal to now tangent of theta, 3 of them. What 3 are there? Does anyone know? Good. That was a tricky one. Okay, using co-functions again. Sine of pi over 2 minus theta. Who is sine's co-partner? Cosine. So this would be equal to cosine of theta. Good job. Okay. Now, cosecant. Who is cosecant? Cosecant's the evil twin of who? Sine. And sine's odd or even? Odd. And when something's odd, what happens to the negative? It just moves to the outside. Tangent squared. Should have gotten secant squared theta minus 1. Someone last hour asked if this was equal to saying 1 minus secant squared of theta. And the answer is no, because here the secant's negative and here the 1's negative. So you have to make sure it's secant squared theta minus 1. So raise your hand if you got about 5. If you got all 5. Raise your hand if you got 4. 3. Okay, so we got to start getting there. We got to start getting there, practicing and using those note cards on Schoology. Friday, I believe. So, I'm going to go over the first problem on the worksheet for today, and then you're going to have time to work. So number 1. X cubed minus x squared. X minus 1. So we're trying to get it down to 1 minus x. Now I have a fraction in this first part. I want to get this second part into a fraction, but before I can do that, I'm going to FOIL. So I'm going to carry this down, and then I'm going to FOIL this all the way through. So I get x squared plus x minus x minus 1. Does everyone see what I did there? I just FOILed. And then in this, my x's cancel, so I'm just going to go like that. So from here, I want to find a common denominator. This is already over x, so we're going to use that. And say it's minus. If I put this over x, whatever I do to the bottom, I have to do to the top. Yes, Holly? one you could, yeah. Do you want to do it that way? Okay. Okay. So then we'll keep this part, and you just want to cancel up here. So we'll have x squared minus x. That's a good idea. I just did it the roundabout way. So then this negative I have to distribute to both of my terms. Don't forget that, so that we get that. These x squares cancel, and then we get negative x plus 1. That was so much quicker. And does that equal 1 minus x? Yep, it's just written differently. We could rewrite this to say 1 minus x. No, we just decided since there's an x here and there's two terms and each of the terms has an x, we just can cancel that x, get rid of one of those and one of those, so it's 2 and just x. So then we're left with x squared minus x, and then for this part we had to distribute the negative, so a negative x squared plus a 1. And then something's canceled and we're left with negative x plus 1 or 1 minus x, the same thing. These two are the same thing, just written in a different order. Questions? Number 2, remember difference of squares. You will thank me for that one because some people were doing some really long stuff. So 2, difference of squares. Other than that, you have 10 minutes to work. I'll be walking around for questions.